Gabi is a technical project specialist with Swine Medicine Education Center, or SMEC, at Iowa State University. She obtained her DVM in 2021 and both her master's and PhD in 2025, all from Iowa State University. She's nationally recognized as an emerging leader in swine water quality and waterline biofilm ecology. Dr. Doughan's work integrates applied research, education, and industry collaboration to advance biosecurity and water management in pork production systems. So please help me welcome to the stage Dr. Gabi Doughan.
Thank you for that introduction. Really appreciate it, and thank you guys for attending. So I know we were talking about nutrition and some essential nutrients before, but I think today what we're going to be talking about is really the forgotten nutrient, and that's going to be water and how we can effectively manage our water systems in pig barns. And so why does waterline ecology matter in swine production? And so most of the previous research that we have on water quality within swine systems has really been focused as water as a nutrient. And through that research, it's really found that pigs tolerate a wide range of water qualities, especially those older pigs, with younger pigs being a little bit more susceptible to different water quality imbalances. And so in our industry, that's led to a lot of assumptions that we don't necessarily need to worry about water we need to worry about water quantity and making sure the pig is drinking enough water so that we're not impacting average daily gain or feed conversion, as water is a big driver of feed consumption. And we don't necessarily need to worry about water quality. However, there's been some more recent research in the coming years that really has demonstrated that water treatment can actually decrease mortality, both in sows and also in nursery-age pigs, can increase production performance in these groups. We also know from more human literature that waterborne human and livestock pathogens can be in water sources that could potentially be sources for pigs, so like surface water and groundwater sources. We also have, anecdotal evidence that, farms that have issues with E. coli, if we treat the water lines or shock the wells, we can help those pigs recover from those, and we can remove the E. coli from those systems. And we also just know we're learning more and more about antimicrobial resistance and biofilms and how those two things are really together. And with our water systems being medicated in swine, we have just a more concern on how are those things interacting with one another, and can we improve antimicrobial stewardship within those systems. And so really, I think there's two primary impacts of waterline ecology in swine farms. The first is going to be how can it impact biosecurity into our farms? And then the second is also going to be how, because our systems are medicated, how does water quality and some of these biofilm waterline ecology types ideas affect water medication treatment efficacy? And so the first thing that we're going to look at is really water lines as a biosecurity risk in our water sources for pigs. And so most common water sources in pig farms are going to be from your surface or groundwater sources or your private wells, with fewer farms on rural water sources which are treated and less susceptible to some of those biologic contaminants. However, when we think about our groundwater, which is a primary source here in Iowa, we tend to think that, well, it's covered by a lot of geology, that water gets, filtered through all these different strata in the soil. However, through the human research, it's actually demonstrated that this is more susceptible to contamination than once thought. And so viruses and bacteria can actually go into really deep wells and can reach those wells rapidly, especially in different conditions. And water itself also maintains infectivity of some of these organisms for longer than we once thought, even if it's in the environment, right? And so my master's was really focused on understanding, can we find pig pathogens entering into swine farms from private wells? And so we had surveyed 40 wells throughout the state and had actually detected PCV2, Cryptosporidium species, and some swine fecal manure markers as well within those sites. And so it's demonstrating that, yes, this could potentially be a biosecurity risk. You'll also notice that PRRS, PED is not really on that list. There's a lot of additional research that this needs to be refined more for our pig-specific pathogens, because the method we were using was really more on the human side. And so there's a lot of additional research that needs to go in to try to understand what the actual capacity and if those organisms are there. But the fact that we found PCV2 and swine manure markers in there is, an indicator that this could be a potential biosecurity risk. The second piece is when I think about, water systems in farms, I think about the source, and then I also think about what's the actual system contributing to the water quality in our farms. So once it's inside the farm, our water systems are commonly open systems, so meaning that different points are open to the environment. So it's going to be your medicator. So your stock solution bucket there, which you can see some examples here. So some stock solution buckets that are, they're exposed to dead flies, mice sometimes get in there, other types of bugs can enter in. We also see that our drop hose is like completely black. So there's biofilm kind of growing in there. It's not, they're supposed to be clear, right? When you first buy them, they're clear. And so we've got some biofilm organisms in there, residual antimicrobials on the inside of that too. And so all those contaminants can kind of enter in through the system. We also have filters, other entrances. It could be, even the cup waters themselves. Although there hasn't been a study directly tying, introduction of organisms from the pig into the water system, biofilms can grow around a lot of different joints and different valves and whatnot in human water distribution systems. So it's not completely out of the scope to try to seem that, there's some organisms that could be introduced by the pig itself. We also have systems that are dead end. So all of these contaminants and other things that go into the system could be, just accumulating in the back of these water lines at those dead ends. And so if you open up a flash valve, usually it takes about 20 or 30 seconds, and it's this brown, gunky water that comes out before it turns clean. And so really it's just a system that, a lot of debris can build up within that. Like I had mentioned, there are also medicated systems. So we're introducing antimicrobials, probiotics, Kool-Aid, I've also heard and seen, to increase palatability, and live attenuated oral vaccines. So we're actually introducing bacteria into these systems. And so how does that all incorporate and influence the biology within that system? We also know that just water quality in general can be pretty poor on some of our farms, and that doesn't necessarily directly impact pig health, but what it can impact is the system itself and how it functions and operates. And so hard water, for instance, or an elevation in calcium and magnesium, when paired with an elevated pH, which is pretty common to have in groundwater in Iowa, and so when we have those things, it can actually build up mineral debris on the inside of those water lines here, like you can see. And so when that happens, it actually reduces pipe diameter, and that can restrict water flow and water access to those pigs. And so we're actually reducing the amount of water that they can consume. We also know that waterline biofilms are a common thing. We have them in our human water distribution system. We have them in our swine distribution systems too. And so this is really a perfect environment for those organisms to thrive and feed off of all these nutrients that are within these systems. And so what can we do about it? The first thing is, hopefully this provides some evidence that maybe we need to consider waterline cleaning as an option on managing these systems. And so the first option is going to be with our terminal waterline cleaning. So that's going to be a one-time disinfectant that's at a really high concentration, and it's not safe for animal consumption. So when we think about, this is more for the grow finish side, maybe if you have the correct plumbing in your lactation or your farrowing rooms, we can, when those animals have been removed, you can apply a terminal line cleaner there. And so this chemistry needs to target both the mineral and the biofilm components. Acidification is something that you can use in order to get rid of both of those things. However, if you just use citric acid, for instance, if you have a fungal problem within your biofilms, you could also exacerbate some of that because fungus actually likes that acidic environment. And so usually between these, a contact time is usually around 12 to 24 hours is what's needed. But if you're routinely keeping up with your systems, you could have a downtime of 4 to 6 hours even with that. However, if this is your first time cleaning your system, you may actually have to repeat this multiple times, once or twice or even more more just to remove that heavy scale-in biofilm within those systems. And so we actually tested this because we wanted to understand how does a one-time waterline cleaning impact biofilm quantities over time. And so we had used a peracetic acid product actually at a 1 to 128 dose. So it was an off-label. This particular product was supposed to be run at a 2%, but most producers have a 1 to 128 medicator. And so we wanted to see what we could achieve there. And so with that, we had a significant reduction. So this is looking at biofilm quantities over time. And so pre-treatment, we had, quite a bit of biofilm. So, we had a statistical difference here between pre-treatment and post-treatment. But then these two values, about 3 days after disinfection, it was not statistically significant. So what does that mean? It means that biofilms regrew within those 3 days to essentially to what it was before. Then you also see that biofilms actually increase and peak because we eliminated a lot of competition within that first treatment cycle, and so then the biofilms were able to grow and kind of feed off of those nutrients, and then they stabled out over time. And so what does that mean? It means that we need to have a plan for continuous waterline treatment or disinfection in order to manage those biofilms long term. When we looked at water quality from this same study, we were not a lot of differences because we didn't actually change the water source, and that makes sense, right? However, we did see differences in those water samples, specifically in coliforms, when we sampled water from the source and then also from rooms. And so you can see that coliforms were actually always higher than those that were coming through at the well. So you can see that the well was contributing to some coliforms around day 14, 21, 42. But overall, the rooms were really contributing to that. And so with our biofilm counts, we can assume that that's a lot of biofilm shedding. So these bacterial organisms that are shedding into the water system. And so really, what does that mean? It means that water sample location matters. So if we're trying to understand what the whole composition of what these pigs are actually drinking, and we're only taking a water sample from the water source, we're completely missing what the pigs are actually drinking when it goes to the nipple, right? It also provides evidence for that more continuous water disinfection over time, because if we have biofilms, they could be shedding into those systems. And coliforms themselves are not necessarily always bad. It just means that they are a potential indicator for similar living conditions for potential pathogens. So for instance, E. coli and Salmonella are coliforms, and so if we have coliforms there, it could potentially mean that those organisms like E. coli or Salmonella could also live in those conditions. And so can you just look into your water lines and see if you have a biofilm problem? And so, yeah, if we look at our pre-treatment, you can see that, yeah, there's some biofilm in there, but it doesn't look that bad, right? However, when we look at our actual standard plate counts and how much was there, I mean, it was quite a bit of bacteria, hundreds of thousands of colonies that we are able to culture. And so when we look at post-treatment, day 1, so this, looks pretty clean, but day 3 still kind of looks like day 1. And so, but if you looked at the actual counts, these are not significantly different than one another. So you can't just look in your water lines and say, yep, it's good, they were clean, it's all good, because the bacteria are still there within those systems, even though visually you can't see that until about day 14, 21, 42. So some continuous disinfection, what does that look like? Really, it's a lower concentration of a disinfectant. It's, and it can be labeled for drinking water in pigs, and it can manage biofilms long term. And so with that, because we're actually feeding, a disinfectant into those pigs, a lot of times they have a lot of regulatory considerations that we need to think about, especially if they are EPA approved, because we don't have extra label use of EPA approved products. So if we have a specific label, we need to be reading that and saying, yep, this is the concentration, this is what it needs to be run at, so that we don't get in trouble with the EPA. So how do you go about choosing a waterline cleaner? Well, there's a lot of different options, and thankfully we have a lot of options to clean our water lines to meet these needs. And so we have, different management factors. So for instance, in a sow farm, we may not be able to apply a terminal line cleaner in every single situation. So, it depends on the type of farm that you're running, the plumbing, are you able to actually run a disinfectant through that, and what the type of plumbing is, what is the cost of the disinfectant and waterline cleaner. the level of scaling and the type of biofilm. Like I had mentioned, there are some differences that maybe you would want to use a certain disinfectant versus others, just based on the type of biofilm that you have. And also your water quality is going to be a really big indicator of which ones that you choose, because some of them prefer different water qualities than others, or they work better in those different conditions. Thankfully, like I had mentioned, there's a lot of different options. So peracetic acid, chlorine dioxide, hydrogen peroxide, and a whole bunch of others. And a lot of times they are formulated in both a terminal and continuous disinfection rate. However, you just need to make sure that you've got the right one, because you don't want to give, pigs a terminal waterline cleaner. That would be really, really bad. So I talked about the biosecurity kind of components within water systems, and now I'm going to really focus on this medication efficiency and potency, and how can our water systems really contribute to decreased medication efficiency within these systems. And so when we think about our water distribution systems, we automatically think about the medicator, right? And we a lot of times assume that our medicator is dosing appropriately. However, I'm going to hopefully provide some evidence that maybe we would need to be considering that a little bit further. Our dirty stock buckets, there's residual antimicrobials. Maybe they're mixing with one another. If you're mixing your oral vaccine in with your antimicrobial stock solution bucket, it may get inactivated. Not really a great system there. Improper stock solution formulations can definitely happen on farms. Low water pressure and flow rate can also contribute to some other challenges, which I'll discuss. And water quality itself can also be incompatible with some of our medications. So for instance, pH, water hardness, some of the trace minerals, they can actually reduce the potency, and I'll provide some examples of that. The water temperature, other present disinfectants, all those things can contribute to reduced efficacy. I also had mentioned antimicrobial resistance within biofilms. And so biofilms have their bacteria primarily that have this protective layer over them. And so they really like to share genes with each other within this type of system to help protect them from other things in the environment like antimicrobials. And so really these biofilms harbor antimicrobial resistance genes. And when we've looked at it, we've actually found genes and demonstration of resistance when we've tested that within these systems. We also know that the protective layer that they form can actually incorporate antimicrobials within that system. So it's just constantly exposing those bacteria to those antimicrobials. And, the drugs that we're finding those antimicrobial resistance genes to, they're drugs that we commonly use in water lines and drugs that pigs have never seen in water lines too. So, and some that are actually important to human health as well. So a lot of things that we still need to work on and study there. And so I had mentioned that, maybe we need to really think about our systems and how we approach water medication in swine farms. And so the project that we worked on last summer was actually looking at a medicator longevity project. So it was looking at, can we take a brand new medicator and see what it doses at, run it for a couple of months, and then reevaluate what the dosing efficiency of that medicator was. Well, this project, we learned a lot of things and a lot of trial and error through there. And we learned that there's a lot more to just dosing pigs than just, making sure that your medicator is brand new or that it's working. There's actually a lot of influences on flow rate, pressure, back pressure on the medicator, all of these different things. And so really some big takeaways that we had here was that mineral scale and flow rate issues really contributed to this dosing inaccuracy, and that even a brand new medicator in this case was not dosing appropriately. So you can't just take a medicator straight out of the box and just assume it's going to be dosing at that 1 to 128 rate. You need to be able to calibrate it and check to see if it's actually dosing at that. And especially if you're using it over a long period of time, some of those things can break down just because of mineral scale and all that stuff. When we actually looked at the manual instructions for install, we had mimicked how a lot of farms have their systems set up. However, a lot of them have, kind of caveats that the warranty on the medicator is only going to be active if there's a filter that's before the medicator or it's installed appropriately. And oftentimes it's not that case in the farm. And so really important to follow instructions of, the manual for your medicator for that install, and then also calibrate and maintain those medicators. I'd recommend if you're at a grow finish farm, just check it twice a year after the turn is done there. So how do you calibrate a medicator? I think when I've surveyed some producers and folks out in the field, I think I've maybe had one person raise their hand that they've calibrated a medicator and have actually maintained their medicator. So how do we go about doing that? So if most of our medicators are going to be at a 1 to 128 ratio, so a 1 ounce per 1 gallon when that moves through. And so like I had mentioned, pressure and flow rate is really going to influence how that medicator doses. And so we need to make sure that those are consistent while we're performing these calibrations. I'd recommend you calibrate it about 2 to 3 times to make sure that it's consistent, because you can get different results. And so you just want to make sure that it's not just a one-off, reading there. And so how do you go about doing that? You're going to prime your medicator drop hose. You'll put the drop hose with no filter with 5 ounces, for instance, and then you're going to put an empty 5-gallon bucket at the end of the medicator there, and just make sure that you've actually measured where that 5 gallons actually is, because a 5-gallon bucket that you get at Menards actually will hold, 5.1 to 5.3 gallons. So you want to make sure that it's actually the 5 gallons that you've marked there. And so if a medicator is perfectly calibrated, when you start the water flow through the system, you should have 5 ounces taken up from, the drop hose here, and then 5 gallons in the bucket. If it's overdosing, then you're going to have 5 gallons taken up faster than the 5 gallons is reached. If it's underdosing, there's going to be ounces left. So you're going to have stock solution or your ounces left here while you have more water on the other side, if that makes sense. So I'd also mentioned, we tend to think about medication efficiency, making sure it's getting to the pig. A lot of the times it's also we need to focus on the stock solution and what's going on there. And so I'm going to provide CTC as an example here. So this was a study that was actually published last year, and it looked at different water qualities and how it could impact performance or recovery of a specific drug. And so CTC here, Penchlor is here. This is more of a chemical CTC standard, and then a different brand of CTC as well. And so you can tell in perfect reagent water, it's pretty stable over time. So this is looking at over a 24-hour period. In soft water conditions, so that's a water hardness of less than 60 or so, we can see it's pretty stable, but we still see some losses at about that 24-hour period, right? However, and this is set at 71 degrees Fahrenheit, which is also important to consider. With our hard water, we can definitely see, at that 12 hours, our CTC standard was sitting at around 50% recovery, while our Penchlor was a little bit higher, but still 70% of that was still active or potent within that system. And then same deal with Chlorinex here. And so with our stock solutions, we can still see if we are mixing those, for 3-4 days, we're losing a lot of drug, and it's not activated, for those pigs to even consume. And you're essentially wasting your money, right? Because that's a lot of money to make a stock solution. And if it's not even working, before it even reaches the pig, that's a big deal. Okay, so then we look at this 95 degrees Fahrenheit here. So when they looked at reagent water, we still see some losses, but not as significant with our soft water and then hard water. Hard water, which again is common on most farms here in Iowa, at 12 hours, it is really significantly reduced, and we are not seeing that efficacy. So you may say, okay, well, is the 95 degrees Fahrenheit, is that really common? Are we actually for our stock solutions? And if we are using an agitator, it may be. So an agitator helps keeps things in solution. It's common, that maybe there's some residual drug at the bottom of the bucket. However, those agitators, if they're constantly running, they can heat up the water in that source. And so a lot of drugs, CTC, amoxicillin is another example, but we can see these decreased efficiencies there. So how do we go about it? You can try to use a timer of an agitator so that it runs for about 15 minutes every 3 hours or so, and then it'll shut off so that you don't have to heat up the water with using that. So again, CTC and hot water can impact the potency over the time, and we may even consider only mixing those stock solutions for 12-hour durations, especially if we have those conditions, versus our 24 hours. Again, ideally 12 hours, but there still needs to be a lot of research on what are the best practices here. So I had mentioned, CTC is an example of this. Amoxicillin is another one. They actually prefer kind of similar conditions, and they're the most studied. A lot of the other drugs that we mix in stock solutions are not, have not had these studies done on them, or they're not publicly available. And so they actually prefer acidic environment, low light, so using a bucket lid on top of these stock solutions can be important too. Agitators, again, can impact stability. They prefer soft water versus hard, and then the time decay, is less than 24 hours. And so another potential solution, instead of just using the farm water for your stock solution bucket, you can also use like distilled water from, that you buy from Hy-Vee or wherever, and use that instead of the farm water. So like I had mentioned, medicators can not be dosing appropriately over time, and so I think it's important to also see what the inside of these medicators look like and what those different components how water quality can impact and have that wear and tear over time. And so this is a piston pump, so a lot of really common medicator on farms, and then this is a diaphragm medicator here. And so the piston pump, it actually directly interacts with the water and the stock solution here. And so there's a lot of mixing that can occur. And so like a car engine, if you're not lubricating that, if you are not, maintaining that system over time, it can break down. And so what happens is that more water would enter in, and then you would dilute your stock solution even further, underdosing the pigs. If we have our diaphragm medicator here, these ones, they still don't have a lot, so clear water comes through here in this mixing chamber. However, we still have some, the concentrated additive or the stock solution entering into the system, although it goes out through not the entire portion, but just a portion of it. So still a little bit better of a design, but we still have drug and water quality mixing in there. So if we have, we've taken our filters out, we have sand coming through there, we have, drugs, biofilms, other things that are, clogging up these systems, that reduces the efficiency of that, can impact, dosing and all of that. And ultimately, that's a direct cost to you as a producer and to the pigs, ultimately, because they're not getting the drug that they need. And so again, you need to make sure that your medicator is actually dosing at that 1 to 128. So there's a lot of other things with these water system designs. So low flow rate, also need to consider pigs don't drink a lot. So they drink about 0.3 gallons per minute, and that's based off a 2,400 head farm. And so, especially when they're weaned. And so if you're applying a medication, maybe, flush those systems to get fresh water out so that the medication actually gets to those pigs faster. Pipe diameter can influence flow rate. There's frictional losses and other pressure things that need to be considered. And if pigs are all drinking at once, you lose a lot of pressure just because we don't have enough water actually reaching the pigs because of the pipe diameter. And you can see how pipe diameter impacts the flow rate, right? And most of us have 3/4 inch pipes, and so our maximum flow rate can be 3.1 versus our 2-inch pipes, we can get 35 gallons per minute through there. And so the last thing that I just want to kind of touch on too is biofilms impacting drug concentrations. This is a really, kind of the next steps in research, trying to understand how do these things interact with one another, and how can biofilm, impact the drug even further. And so here are some things. What can I take away to try to improve waterline ecology on the farm? First thing is going to be test your water quality, and test it, at least 1 time per year in multiple locations. Also clean your water lines. That biofilm mineral deposits can really impact the pig, and maintain water treatment efficacy through using clean stock buckets, calibrating your medicators, and just making sure that you're getting that efficiency out of your medications. And so we've got a lot of resources available to producers through the water line system management. So we had collaborated with IPIC on this, and we put together some videos too. So here's a kind of a summary of what we had talked about here, and you can scan that QR code. A lot of people I want to thank, for this research, and I'd be happy to take any questions if I've got any time.
Got time for a quick question if anyone's got one? If not, let's thank our speaker once more. Oh, we got one back there. Sorry,
I was in the back. So you mentioned calibrating twice a year at the end of every turn. Is it more of a timing thing, or is it gallons per minute? If you have a really sick group, if you're doing continuous line cleaning, will that have more wear and tear? Does that compensate for it, or is 2 times a year enough?
Yeah, so that's a great question. So it's kind of a general. We don't have best practices, and we're kind of learning as we go because this is the first time we've really assessed it and looked at it. So I think that, yeah, 2 times a year is just kind of a general, maintenance thing. But I think a quick thing that you could even mentally check is, okay, is the flow rate, the amount of stock solution that I make up, is that actually, getting delivered to the pig in the amount of time that I've allotted, or based on the water consumption that they have, and does that seem even? So for instance, if we make up, a stock solution for 24 hours, we have our gallons of what they consume. Is there still stock solution left over, or did I run out of stock solution? And kind of troubleshooting some of those things, because that may be a trigger that, hey, my medicator is not dosing appropriately. So still a lot to learn from this, but yeah, I would just recommend twice a year now. But if there's things that are maybe off, maybe you want to check it more frequently than that. Good question. Thank you.
All right. Thank you, Gabby.